Welcome to Next in Tech, an S&P Global Market Intelligence podcast where the world of emerging tech lives. I'm your host, Eric Hanselman, Chief Analyst for Technology, Media, and Telecom at S&P Global Market Intelligence. And today, we're going to be discussing generative AI, large language models, and a lot of the underpinning technologies that we'd actually been putting to work in the last few episodes. And with me to discuss this are Peter Licursi and Chris Tanner. Welcome to the podcast to you both.
Good to be with you again, Eric.
Yeah, thank you. Thanks for having me.
Well, and it's great to have you both here. We've been going through all sorts of different pieces of the hype, the furor, whatever you want to call it, about ChatGPT and OpenAI and the idea of generative AI and a lot of these different pieces. But I wanted to take a bit of a step back and talk about something that both of you are working with day in and day out, which are really large language models and really sort of where they fit in this much larger conversation.
Yeah, it's a great point to discuss. Rightfully so. ChatGPT has received an incredible amount of attention in recent time. I think that it is the single most important and compelling piece of technology, at least on a computational standpoint, that we've ever seen within humanity. It's not perfect, but this is a huge step. And yeah, it stems from a flurry of recent interest within large language models. So to be clear, ChatGPT is an example of a large language model. And it's not the only large language model that is compelling, but it's really good.
Within humanity, wow.
Yeah.
That is big, huge, and impactful.
Yeah.
All right. What's for audience? Can we break it down? And what are really the basics behind large language models? And what is it that's making them so transformative?
Yeah. All great questions. And to be clear, I did say that it's the single most important computational model. We've done a lot within humanity, a lot of amazing achievements. But in terms of a computer model to estimate something, to do something, it is amazing. Yeah. So language models, if we zoom all the way out, language models are just one of the problems, aka tasks, that natural language processing has been focused on for decades. All right. So this field of natural language processing, if we zoom even further back, just to make sure that we're all on the same page, natural language processing is the field that is concerned with trying to automatically understand human language. And usually that is in the form of text, all right? Because text is everywhere in the world within our digital age, from web pages and social media and so on. It only makes sense for natural language processing to receive more and more attention and for progress to happen. And now if we start to zoom in a little bit about language models, it is the case that language models have been worked on for decades. And ultimately what they try to do, this is going to get a little nerdy, a little technical here, but fundamentally a language model simply tries to estimate the probability of any sequence of words. So you can think of this as saying, how realistic is this sentence? That's basically what they're trained to do. There are many ways to do so. There are many ways to go about that problem, but they're basically just trying to understand, I'm putting understand in quotes, understand language. And the amazing thing that's kind of allowed all these innovations to happen is that although language modeling, as I just described it, it's only one of the dozens of tasks that we focused on. Well, it turns out if you can do a good enough job at it, it really enables doing well on essentially anything else within natural language processing that one might care about. From translating languages, trying to summarize documents, trying to understand the sentiments that are discussed, and literally hundreds of other tasks.
Everything from translation to inferring intent, all sorts of capabilities.
Yeah, exactly.
So when you think about what we're really doing with large language models, I mean, with ChatGPT, it's really becoming the front end to what is that generative environment that sits behind it. It's really interpreting what the requests are. Or is that as far as it's going? Is there more to it?
I mean, you are right. ChatGPT has an underlying model. That is the thing that allows the opportunity and allows us the capabilities to do what we're doing with it. But yeah, it has a public-facing website. It could have easily been the case that they chose to not make a public-facing website, and only the research community would have known about it and have become super excited about it. But yeah, there's a public-facing website, and now people are able to really see all the amazing stuff that we're starting to create within the research community.
And so I guess what, from our perspective, I mean, what are we doing with large language models? And I guess the question that we wind up getting a lot is, what could software vendors and services vendors like Microsoft do?
Yeah. So we at S&P and at Kensho specifically, we recognize the importance of language models. So I've been at Kensho almost exactly 1 year. And for context to the audience, my background is in research. I've been doing machine learning research for about 20 years, specifically natural language processing for, I don't know, about 15 years, depending on how you count. So it was rephrased another way, it was quite obvious upon my getting here at Kensho that it would be really important for us to develop our own language model. So from day one, this is of huge interest to me. So we've been building our own finance and business-based language model, thanks to all of the incredible data that S&P has.
Well, and that actually, I think, points out an important aspect of all of this, which is that when you're building models of language, you're really tuning that model to speak the language, or to understand the language, I guess, from a better term, of that particular application or use. And because there's a vocabulary, there are idioms, there are all of those different aspects of language that are very specific to the sphere in which it exists.
Yeah, it's a good question. Basically, there is kind of some pros and cons of what you just described. If we rewind about 7 years ago, it was only then that we were at the cusp of starting to ingest into these large language models just tons of data. So the good thing is that we were able to finally cross a threshold in terms of, if we throw so much data at these language models, we can start to get these kind of general purpose, amazing capabilities that we had never yet seen. But the con of that, kind of the caveat to it, is that, to your point, it is still quite general. These models oftentimes are trained on essentially all of the data on the web. That's kind of an approximation, but it is just enormous amounts of data on the web. We're talking on the order of 400 billion individual words being ingested into these language models. But yeah, the price to pay is that you're then developing a very general purpose language model, and it very generally understands how humans speak. If you want something pertinent to business and finance, yeah, it might have a cursory understanding. It might understand certain key terms. But if you're going to ask that model, for example, what is the market cap of a particular business, or who the CEO is, or when something was founded, who knows? It may or may not have that capability to know that and to leverage it.
Well, if you think about the question you just asked, what's the market cap? There are a whole set of inherent pieces of information that might not, in a generalized model, might not be well understood. You're talking about market capitalization. You have to know that market cap is an abbreviation for capitalization. There are all these different aspects that, depending upon the setting, you've got to get relatively specific about.
It's interesting, Eric, because I think in playing around a little bit with ChatGPT in some of these specific contexts around business and finance, what I find most impressive about ChatGPT in particular is it is extremely good at interpreting the meaning behind a prompt or a question or a task. And that's unbelievably impressive. However, what has given me pause in interacting with it in terms of kind of specific business or finance use cases has been, number one, just kind of a lack of certain depth of knowledge when you get kind of specific around certain questions that we know, for instance, our clients might be interested in. But furthermore, it is sometimes disturbing the confidence with which the machine provides even evidence to support like an erroneous claim, for instance. And so in a business context where it's really important that information is accurate, and also that it's practical to run something as large as a language model of this type, I think it's really key that we kind of hone and specify these models in kind of specific contexts and using very specific data. And I think, to your question around how will software vendors, how will enterprises make use of these large language models, I think it will be in just that way, harnessing data that is specific to a use case and applying these technologies in a way that can kind of speak to those particular use cases and speak that specific language as you were framing it.
Well, and you've made an important point there, which is that there are two parts to this equation. There's both the interpreting of what the request is, and then the act of filling that request. And while the interpretation may be wonderfully accurate to understand the implications and the intent of the request, you then have to back it up with data, and then we get the digital watch problem, which is, the digital watch looks to be particularly accurate, but of course is only as good as how accurately it happens to have been set. And when you've got something like a return from or a prompt like that sounds authoritative, is able to pull out sources and cite them, however improperly, it can seem as though we've now got a particularly authoritative response. And that's a challenge.
Yeah, it's definitely a challenge. And I like that analogy there with the digital watch. Yeah, I mean, given the era that we live in now with, just widespread misinformation, I think you're hitting on a very important part, that it can be dangerous knowing what we can generate, not just in terms we here as a species, with all this technology that we're developing. This isn't just a statement about ChatGPT. This isn't just a statement about language, but about images, about language, about videos. It's a very simple question that's on a lot of people's minds, but very pertinent question of where are we going with this technology and how can we possibly rein things in terms of correctly understanding what is real and what is not. And these were things that weren't really even talking points because they didn't need to be just a few years ago. Not to go too much on a tangent, but just provide context. It truly was the case that not even about 3 years ago did we have the ability, we as like a research community, did we have the ability to do a good job of understanding what somebody might be asking a model, So just so much has changed in the last 3 years.
Well, and I think there's another piece to this that, Chris, you talked about the volumes of data that are needed. I mean, I remember some years back, looking at machine language models for image recognition, and that the leap that got made when we simply could provide, so much more data. That when you asked relatively simple things like, is this a cat? Is this a dog? The classic sort of image recognition question, because they're both kind of similar. They're both kind of furry. And the models trained with, millions of images did pretty well. But then when you started getting up into billions of images, suddenly we started to get to a point at which we were really able to discern, or that we were able to build models that were able to discern much more nuanced distinctions. And when we get into large language models, that's a problem that's even greater. I mean, you were talking about billions of words. Now we get into that question of what's that data source? Where does it come from? What's the quality of it? We're already starting to see some of these questions kick up around who owns the data? What are you building it out of? What control do the owners of that data have and how it's used? We're starting to get into some really, really complicated issues around the data, the training data that's needed simply to make this stuff work well.
Yeah. A lot of great points in what you just said. It is usually the case that technology outpaces policy, right? The technology happens first, and then we're trying to figure out, okay.
Always.
Yeah. I mean, because it's hard to predict where technology is going to go. And I'm using technology in the broadest sense here. So this is where we're at now. And technology in this space is becoming unbelievable. And to your point about kind of the training data and who owns it, people are starting to push back a little bit on the kind of performance that these large language models are able to develop. When we talk about like quantitative numbers, so there are a slew of benchmark tasks, on the upwards of 200. Like there's some for this one suite called Big Bench, bench being short for benchmark. And so anyway, to be specific about what I'm trying to say here is people are pushing back on saying, well, can we really trust a particular number? Let's just make up an example here of like 80% accuracy, because we know that these models were trained on huge volumes of data on the web. And it's not inconceivable to imagine that somewhere on the web was some example of exactly what we're going to test it on later. And for the listener who may be a little unaware of the distinction I'm making here between a test set and a training set, or an analogy that I like to give is kind of, how would you assess a student who's trying to learn something in a class? The student has some training examples, and ultimately you want to measure how well that student can perform. And the dilemma that I'm raising here is that researchers are raising this dilemma that can we really trust that the student can perform a grade X on a particular exam? Because it might be the case that they saw some of these exam questions earlier.
Well, if you're hoovering up the entire contents of the web more broadly, there's a reasonably good chance that you might have come across a particular case. And to your point, you could simply reproduce that particular example and off you go.
Yeah.
Well, I think actually you bring up a really important point there, Eric, which is that by training on the entire internet, of course, that's going to make this technology incredibly impressive when it comes to all manner of tasks. And I think that there are a number of people rushing to downplay the importance of this technology in the world of business, mostly, to be perfectly frank with you, out of fear for disruption. And I do think that human beings are sometimes want to, I guess, bury their heads in the sand or be in denial when it comes to really important innovations of this magnitude. But I also think it's really important to say that when you're training on and basing your responses, as this technology does, on, let's say, almost the entire internet, there are downsides to that. And that's going to be lack of depth of knowledge in certain fields, potentially biasing information toward what is kind of popular. And one of the things that we've found in exploring our work in this, and Chris and the team have done a really excellent job on this, is seeing where in the field of business and finance we can kind of identify areas where that depth is really important. And so you're able to, by honing that, by kind of honing and fine tuning that training data set and providing the models with specific data that is pertinent to the use cases that you're envisioning, you're actually able to create a lot more accuracy and reliability. And because you can control the data that you're providing the models, there's a lot more confidence that you can have as a provider of this technology or this information to consumers of that technology and information. I think that point is important because it's also a matter of kind of practicality and cost and efficiency, because of course, many of the kind of doomsday scenarios that many businesses, I think, are facing around ChatGPT are not very realistic, mostly because deploying this model as it currently stands in businesses across the world really is not feasible, given the amount of cost that it takes to kind of run this from a computational standpoint. But if you can provide the models with more fine-tuned data, and I think Chris can go into more detail here, you're actually able to produce more accurate results for a much lower computational cost. And I think that's where you're going to start to see the application of this technology really drive. And that's certainly what we're pursuing at Kensho and in partnership with S&P Global.
Well, because by constraining what you're training the model on, you now can understand what the total set of possibilities are that it's engendering, right?
Yeah, exactly. All of this depends on one's exact use case. But if one knows that they're interested in a very particular business, very particular, industry, it is, likely the case that if you can give whatever language model, I'm not just talking about ChatGPT or any other generative language model from OpenAI, but if you can provide any language model with more specific data to your actual use case, it is only going to help you. And then the only uncertainty is in terms of, well, how much specific data versus how much general data, what one's compute resources are. These are all kind of variables to this equation. But yeah, there's no limit to kind of the value of having really high quality data to the use case that you care about.
And Chris, I wonder if it's worth going into some of the actual technology upsides that large language models and investing in large language models can produce, because one of the things that's been so fascinating to me is seeing that by investing in this area of natural language processing in particular, you actually stand to benefit as an organization by proliferating that capability within other areas of natural language processing. So for instance, you're able to do, you can invest in a large language model and that will help you with all manner of other tasks, whether that's something like summarization or sentiment analysis. And those are certainly things that we have been exploring here, and that I think is a really great benefit and a unique benefit of large language models.
Yeah. So regardless of what industry one is in, anytime that industry concerns human language, like I said earlier with, NLP concerning just a slew of tasks. Well, I think if you care to do any of those tasks, such as having a chat bot to help customer service or to translate languages or whatever, then it is worth investing in language models. The only asterisk here is, what does that investment look like? Depending on the size of that company, depending on just kind of the nature of it. Does that investment look like using some general purpose language model that will be provided to the public via an API? Or does that look like you invest by having your own research team build up their own language model? And even with that, there are many ways to go about it.
So what are the kinds of things that you see as next steps for large language models and where they're headed? Do we get to a point at which we can have some level of indicators of confidence? Are there other aspects that you're looking at tackling? Where do you see this headed?
Yeah, great question. So there will be no shortage, like there'll be no end to the fact of people just throwing more and more and more data at these language models to build up bigger and bigger models that are undeniably better at these kind of general purpose abilities. That will always happen. But kind of independent of that, there will be continued research, and this is like a blossoming set of problems that people are working on in terms of interpretability, explainability, bias, and fairness. So for all three of these areas, people are essentially trying to get at, what do these models really know? What do they really understand? How biased are they? And then also just trying to understand, how can we better use that information? So even if we can quantify, the model knows X, Y, and Z, what is the best way to get that information out of it? So there's a very popular and impressive line of research called prompt engineering. And it's a pretty basic concept. And that is, when we're asking questions to the language model, can we phrase our questions in such a way that we can elicit the answers that we care about? And if we go a little bit beyond that, one can also say, well, can we kind of in our question seed it with kind of an idea of the type of stuff that we want? So you're kind of helping out the model. You're not even further training it, but you're just saying, hey, model, here's an example. I care about stuff like this. Please give me the information that I want. And it should be able to follow suit with the kind of format that you provided with. So that, again, is called prompt engineering. We're seeing tons of exciting research in the past year or two. So to answer your question, yeah, there are 3 or 4 research areas where researchers are pouring their efforts into. So that's what we're going to see in the short term and probably long term also, probably at least the next 10 years, 15 years. I mean, it's kind of unimaginable to imagine any of those lines of research stopping. People will always want to have a better understanding, because we need a better understanding of what do these models actually learn? How do we interpret this? How can we trust the decisions that they make?
Well, it sounds like these are all issues that are tied into the practical use in terms of how enterprises are actually going to leverage these kinds of capabilities. Things like how do you prompt it effectively to get what to more specifically define what you're trying to get, and how they actually put that to work. Are there other pieces that enterprises should be thinking about?
I think it's really fundamental what Chris is talking about around kind of transparency in terms of how the models are making predictions, not just for the producers of the technology, but also for the consumers of the technology. And, certainly at S&P, we are, in the business of providing global markets with really concrete, accurate information so that they can make decisions with conviction. And at Kensho, our goal is to kind of push innovations in technology that enable that mission. Where I think it's really key is to not only be able to kind of create the underlying technology in a way that has specific data that can be tailored to a use case, but also to give the end consumer a little bit of insight into how that process is being undertaken. And so obviously this is a kind of cutting edge technology, and there will be more developments in the next few months than we can predict right now. But I do think that in terms of the concrete application for enterprises, it's about kind of honing the technology with data for specific use cases, and then being able to provide a little bit more insight into how the kind of generative output of the model was arrived at.
Paying a little more attention to what's behind the curtain.
Yeah.
Wow. Well, this has been fascinating. Thank you both. But unfortunately, we are at time. It has been great to get a background into some of the technologies that we've really been kicking around over the last few episodes, and to look at some of the mechanics and some of the aspects that go beyond it. So thank you both.
Yeah, thank you, Eric. Always happy to talk about these very fascinating topics. So I appreciate the questions and always happy to talk further about them.
Thanks a lot, Eric.
And that is it for this episode of Next in Tech. Thanks to our audience for staying with us. And thanks to our production team, including Carolyn Wright, Ethan Zimmon, and Syed Waji Abbas on the marketing and events teams, and our studio lead, Kyle Canulosi. Join us for our next episode, where we're going to be looking at the tumultuous merger and acquisition market. Brendan Daly is going to be back on to talk about what has been an interesting end to last year and his projections for the year ahead. I hope you'll join us then, because there is always something next in tech.